So before I start with the lecture, I'm just going to quickly, so I have prepared a slide. And I'm going to upload the update. I just finished it before the class. I'm going to upload the update before I go. So essentially, proper exporting of that PDF file that I tried to show last time, that worked just fine on my computer because I had stuff installed and I didn't even think about it, is requires additional software. And this is actually MikTeX for Windows and MacTeX or some other, any kind of tech studio that can provide that. So as long as you install that software on Mac, I think it should work without a problem. And then you just go and restart your Anaconda or your Jupyter. In Windows, it's a little longer procedure, but it's really the same thing. You will need a command prompt. Everybody knows what I mean by a command prompt? Okay. So command prompt is actually a direct way to talk to your computer. And on Windows, you have a command prompt. On Mac, you have a terminal. And on any kind of Linux machine, you have terminal. Most of this Windows-based software, where you click on things and kind of you intuitively find your way, that's the modern expression. There's always literal commands, line by line, and scripts that are behind those clicks, okay, that are driving everything that is happening on your computer. Most effective computing happens when you actually create scripts that automate some job that you're supposed to do. So at some point or the other, you will need to introduce yourself to your command prompt or terminal. Okay? And in this case, it's required so that you add some software to your Anaconda. So you need to go where this Anaconda is installed. Again, this Windows clicking and browsing is making us lazy in knowing where things actually are on the computer. But they actually have designated folders, and your computer is pretty organized about that. Okay? So often to actually execute something, you have to be in the folder where something is the main organization folder for that application. Okay? So if you don't, and this is where search helps on your computer, so you can just search for Anaconda 3. In my case, well, one Windows machine that I had access to, it was in C users mash Anaconda 3, and in another one, it was in program data Anaconda 3. This is basically difference between installing something for one user versus installing something for everyone on the computer. In any way, when you search for Anaconda 3, and it will be obvious that this is your main Anaconda 3 directory. In that directory, this is, whoops, then you just need to go and go to a subdirectory called scripts. Whatever this directory is, cd is command for changing directory. You will actually often see me use it in Spider or maybe not in Jupyter, okay? Because I'm the old school. When I started computing, I'm not going to mention the year, it was a PC286. When I was 14, and we have to go, actually command prompt was the way to go back then, and on a Windows computer you had to know how to change directories and move around, okay? So I have some fond memories from my early computing introduction. And then you just say this is actually installation command. So you're used to clicking on some software that will just execute, correct? Whenever you're installing something, an app on your phone or your computer, there is actually a line command running behind that, and this is that line command. And you will just type in conda install -c conda forge MikTeX. And when you're asked the question, just say yes. Okay, move on. And then you restart your Anaconda, and things should work. If they don't, please email us and we'll figure it out. In any event, for this homework, if this is not up and ready, it's just a prettier printout, you can always print from your browser, okay?
You can print Microsoft print the PDF.
Yeah, that's what I mean, print from the browser. You save to a PDF from the browser. It's just that the output is better formatted when it's done this way. That's all.
How quick the predators view?
I'm trying to, and it's not, okay, come here. So when I switch here, swap displays, it's not working.
So let's just stop. Oh, why stop?
Just control. Okay. Presenter view.
There should be
I
a
think
place
it's gonna still do the same thing. Yeah.
Oh, let's change something.
And I've been trying to deal with that, but it's kind of bugging me in both classes I teach.
Well, maybe we can just do it in this way because it's larger.
It's larger?
Yeah.
Is this better than the other view I've shown? I have trouble. Its main display that should be here is actually shown on my laptop. Go here. So is this swap displays? I've tried that, and that should work. That's the. Okay, let's try. Let me try actually from here. Maybe I need to swap from here.
No.
No. So see? So I can't reach that thing link up there. And if I do swap. Anyway, is this okay? Is this doable? Alright. So before we continue our plotting story, let me review a little bit of what we've done so far to create arrays. What is the difference between these two? What is the difference between these two? It's still even, just like what is the even difference? Let's type it in. Type in these, both of these. And report back how many points do I have in my 1D array X. In the first case, how many points you can do in Jupyter? Okay, do we need to review how to get there?
No, I'm already in Jupyter.
All right, you can do it in Jupyter, you can do it in Spider, but let's do it Jupyter, it's kind of easier. So what is the difference? You're like, between what? See, by the way, this is the terminal window that tells you what is executed. These two.
One's 15 over 0 to 100, and the second one it's pretty much on the list of 0 to 99, with arranging numbers between 0 and 100 spaced by 1.
Right.
And the second one, it's, well, I mean, the first one is arranging numbers from 0 to 100 spaced by 2. Or
It's just,
100 minus
it's
0.
just there's 50 numbers.
There's 50 numbers. It figures out what the spacing should be for 50 numbers. Okay? So essentially, in the first one, you're controlling how many points you're going to have in between, and in the second, you're controlling the spacing. Now, in case of spacing 1 between 0 and 100, I can nicely fit spacing of 1, right? Sometimes that's not the case, if you're asking for spacing 7, okay? And then it's just going to figure out and modify the endpoint to be smaller than 100 but close, okay? And here and there you can actually enforce it to add that last point of 100 to it.
What
So
is
there
that?
are
What is the zero representing?
starting point. So starting point of the range and ending point. Let's try just for kicks. Flip the starting and ending point. Do you get anything? Try the first one, lin space. It's 100, 0, 50. Is it programmed to figure out what to do? It is. You get 50 points and they go from 100 down to 0. So in this case, it's actually programmed. If you were in MATLAB in last semester, you'd get nothing. Say, I can't go. The spacing should be -2. Or something of that sort, right? So, or try with spacing. Try the same with the range. Can you figure out that the spacing should be -1?
Is there a reason why whenever you use the range one, it ends on 99 and not 100?
Yes, it's trying to fit, so basically less than 100. So Python, for whatever reason, is always programmed for that endpoint to be something less than. So it never really gives you the full range. It actually annoys me when we had the matrix arrays. You tell it, oh, give me rows 0 through 2, and then it gives you 0 and 1. Give me that 2 as well, but oh well, it's not programmed. Again, it's not programmed that way. These are the small things you simply have to know, and you get them by practice, okay? So does arrange work if you put 0, 100, and 100, 0, and 1? No, because you need -1 as a spacing to go between those starting and ending point. So first one figures it out, second one wants to be really precise, okay? So in lin space, it's okay to go down, it's just gonna fit in 50 numbers in between. But math doesn't work out unless this number is negative if you put 100, 0, and 1. So those are small things you acquire by practice. So today we're going to do plotting, and I'm going to repeat the example that I did at the very last thing last time. So one thing to know about plotting on a computer when you're required to plot it is that you have to have data to plot. Okay? Even when you have a nicely defined function from your calculus class, okay? F of x is sine of x. We know everything that there is to know about sine functions. Okay? There's plenty of knowledge about it. However, to actually to plot that data, you need actual points, a set of points, and values of sine of x at those points. Otherwise, there's nothing to plot. So when plotting, you're plotting points. So this is where this arrange and lin space will come in really handy, because I also want my plot of sine function to look smooth, like they're using smooth. But to plot smooth, I have to have a lot of points along the way. Okay? I can't have infinitely many. Computers are finite, period. As mighty as they might appear, there is finite space on a computer. So I can't plot infinity number of points. That thing exists in your calculus class. Okay? Not here. So basically I can plot a very large number of points. I still have to create that large number of points. Okay? And then I have to compute my sine function or whatever function, or maybe I simply have data coming out of my Verilog that I'm plotting. Okay? So I'm going to plot those points, and I need these pairs of x and y's for the basic plot. Okay? Now we're going to also introduce a new module. So there's an entire module that deals with plotting, which is called matplotlib. Okay? And specifically, we're going to use pyplot submodule of it. So you're going to have to import it every time you want to plot. And the very basic function we're going to have in there is plot. So the function name is plot, but you have to give it, in this case, there are two last names. Okay? I have only one for me. Okay? I have only one name and one last name. Oh well. So basically, to clearly identify which plot function, I have to give it both last names and then the first name. Okay? And then we plot. So in a very basic plot, it's always going to be plot x, y. X and y will have to be my arrays, 1D arrays of values x and y that I want to plot, and there has to be matching number of them. So I can't have 50 on one and 49 on the other. Otherwise, I'm going to have errors. And the rest is actually going to be just dressing this plot up, okay, with labels, legends, and so forth. So let's get going. If you want to know more, and actually a lot of these examples that are working, I have adapted from the pretty good resource online, which is matplotlib.org. Okay. And there's lots of examples and tutorials and so forth, okay, and documentation overall. So when you need to plot something for a different class, we're going to do a subset here. But think about this as your tool. If you can think about it, you can plot it. If you've seen it somewhere, it can't be plotted, and it can't be plotted in Python too. So in that case, you can find out how to plot. You can find an example that looks like it on this website and figure out how to plot whatever data you need to impress someone, your professor or somebody you're working for or so forth. Okay? So just think it's possible. Whatever it is that you think you need to plot, it is possible, so you can research how to do very nice plots, and effective visualization is really important. All right, so let's do this, what I call bare bones plot. We're going to import NumPy. Second import is not that important because the only function we're going to use is plot, and that is in this third line, import matplotlib.pyplot as PLT. And then I'm going to create my data. That's the first step. I have to have data. And it's really just going to be a simple sine function. I will give myself data between 0 and 2p. Okay? I decided to use a range and provide a spacing of 0.05. And then I'm going to compute sine of that data and plot it. And I'm gonna go and do that with you. I'm gonna open a new one. So. So now I'm going to call this first and last name as one name. This is just to make a shortcut. This is my data. If you like linspace, go for it. So again, create data, plot it. That's the basic logic of plotting. And shift enter, shift return is going to execute this. And for some reason, I sometimes have to execute it twice. Here we go. Looks smooth, eh? And there are certain default decisions about how this plot is going to look like that are made for me, which I'm okay. I'm okay with blue color, straight line. I might want pink today, but I can modify that later. Now let's just increase the spacing a little. Let's do something just to see what the difference will be. So now I changed something in that cell, and I just do Shift Enter to execute it again. Now you can see this finite number of points. You can actually see lines in between the points. Do you see how crude it is now? If you change the spacing to 0.5, you get something like this, right? So that's where my data is. My data is this. In between is just a straight line. But when points are very close, straight line in between goes smooth. Okay. So again, it's plotting only the data you gave it to plot. So again, in a basic plot, the size of these axes, the type of the line, is it going to connect with the line or leave the markers? That's all just being decided for me. And I might actually want to change that. So let's now go on and actually change things. So if I want to identify the axis, okay, you can actually work in that same plot, add different things, and add them one by one and see how they show up. So let's first do X label, which is my X-axis label. And it's also in this family PLP of functions. So we're going to do X label and Y label first. So when I add that, I execute, and now I see, I have a label for my x-axis and label for my y-axis. Again, just by doing X label, Y label. What you do here is up to you, yes?
If you're, instead of naming Y, you named it like H, then would you say plt.h label?
No. So for plot, it's X and Y. So the command is X label and Y label. What you call it as is, here you can, I don't have to name it that way, okay? It doesn't have to make sense what I name it, right? Well then, again, computer doesn't know, it's just executing. It's not judging whether it makes sense, okay? As long as it can figure it out, it's gonna put whatever it is that you put there. Except that this is not a Masha function, this is a sign function. You can do title, my pretty plot. Or if you don't want to be cheesy, then you say my first plot. Or whatever it is that makes sense for you to say. So there's X label, Y label, title. Technically, I can do these things after I plot. Here and there. So this set of commands can be actually done after the plot command. Here and there, they might be lagging in execution if you do that. So you might need to if you define everything you want about the plot and then plot it, that's the safest. But it should work wherever you place these around. Okay? So I can add my X label, Y label, title after I plot something. It's not a big deal. It should work out. And if not, you can actually force it to show things. Or just replot them again or something like that. Okay? Okay. Next thing that I'd like to do is just do a little tighter axes. Most of the time, the computer will be actually pretty good about judging what type of axis you need. However, sometimes you want plot to look precisely the way you want it to plot for a reason. Let's say that you have multiple plots next to each other, and they all need to show the same type of axis so you can easily cross-compare. Okay? Then you want to enforce. And if you want to enforce, you're going to say, hey, give me this axis, and then you're going to give it, this is x limits and y limits. Okay? So there's define both limits. So 0, 2 times np pi, minus 1 and 1. So these are my limits. Again, x limits and y limits. If I had z limits, I would add z limits too, but I have only 2 so far. And for kicks, you can actually just say grid is something that you can turn on and off. And on and off goes by true and false, which are logical variables, true and false. So I'm just going to say, turn on the grid, please. So now when I execute, I have a grid on. I have better defined axis. I can see that my little NP arrange did not go all the way to 2 pi. You see a little thing? It's just 1 less than 2 pi.
How are you making it?
Because I'm using a range. I could do lin space instead.
What if it doesn't print? I mean, when I press return, it doesn't print.
It doesn't print what?
The
I sometimes just do twice. Yeah. For some reason, it just kind of as if it gets stuck in the communication between Python thing and the web browser thing. I noticed that in notebooks much more than in Spider. So I'm going to just give it 100 points here as a difference with lin space. And then I'm going to go all the way. Did everybody catch this slight difference of not having this last point here with the range? No?
Wait, what do you mean?
When I had a range, okay, then this end point is taken as a strictly less than. So it's going to be 1 spacing less than that point, which I find annoying sometimes, unless your spacing is precisely fitting into that interval, which it's likely not. So I like actually, my personal preference is lin space. Give me 100 points and make it a strict percentage. You could do, huh?
Change it to 100 like you did right there.
Uh-huh.
And I no longer have a line.
You don't have a line.
Like scroll down to your graph. Yeah, that line right
You have
there.
points?
That's the only thing you changed, right?
Yeah.
Because if I had
The line was. And all I changed was the same thing you did.
It went by spacing 100. It tried to do spacing 100 on a 0 to 6. That's why. Do you realize?
Yeah, what was the range?
So if I do a range, this is learning. If I do a range here, it's not going to do anything. Why? I'm asking it to do a spacing 100. So this is when you type in a mistake. It's doing precisely what I told it to do. It's trying to do spacing 100 between 0 and 6.28. Spacing 100 between 0 and 6. Result is 1 point or none, right? So you're not going to get a plot. So don't panic, look at it again. Sometimes it's hard to spot your own mistake. Very hard. Ask somebody else to look at it, or just start retyping all over again. Okay? And then you'll catch what you did. And it's going to happen over and over again. Patience. Okay? Computer is doing precisely what you told it. Yeah. So don't do a range here. If you change it to 100, do lin space. So there's all kinds of things you could change. And we're going to play with that next. Because often I need to plot multiple things at the same time. So I need to precisely tell computer, oh, please do this and this type of plot, this type of marker, this type of color, this type of this and that. If you can see it, you can change it. There's basic colors. These are basic colors. You can define much more colors. But these are going to be the set of what you need. Okay? You can do yellow, black, white. Well, don't do white on white. You're not going to see much. Magenta, if I wanted to match my shirt today. Cyan, red, green, blue. You can define the style of your line. Okay? It can be solid, dash, dot, and dotted. Okay? And then you can have type of markers. And this is just a partial list that fit on my slide. There's much more. What you will need to do, I'm not going to ask you to memorize all of this, but certain basics like blue color and red color and black color, okay, as well as the point marker, circle marker, and maybe one of the triangle markers, right? You need to know 3 or 4 markers just to be operable and know that you can look up all of the rest. And where you can look up, Matplotlib has extensive documentation. And you can just Google it and find it. Okay? But again, remember 3 or 4 markers, 2 or 3 types of lines, and 2 or 3 colors, and you're good for most of the intensive purposes of what you need to do plot. So let's do multiple lines. We're going to do next example. I'm going to add cosine function. Right? So I'm going to plot sine and cosine. I know that I have a phase that shift between 2 of them. Okay? And then I'm going to simply designate, hey, give me, this time I don't want default choice of whatever Python would do. I want red circles for my sine, and I'm going to label it sine because I want to add a legend. And I want pluses, blue pluses. So red circles, blue pluses for my other one. And I'm going to add legend to the plot. Okay. So first thing is define extra data. I need also cosine of the same functions x. Okay. And then I'm going to plot them both, and it's just going to keep adding plots on top of each other. And then you will just add legend to it. So I'm going to work within this same example. I'm going to say my second set of data is cosine function. Let's do first simple test. What happens if I just plot both of them? What are the default choices that it makes? So in the simplest of the cases, just plotting things, I can just say plot first one and then plot second one. Well, chose reasonable color options. And if you're colorblind, you have a problem, so you have to fix that, right? So you want to design your own colors. And that's actually an important thing to notice. If you're doing a presentation for a large audience, you can count on some people not distinguishing red and green. Okay? So you're better off with some choices that don't have red and green either. So having different markers helps with that. So I'm going to say, hey, I'm just going to add to this now. Make it red and make it circles. And label it as sine. And what was the blue pluses that I wanted? Okay, blue pluses. just to stick to my plan. Oops, I don't have to redo. Blue pluses and label as cosine. And now that I have two types of data, I do like having a legend. So I'm just going to say, hey, things are labeled already. Print that legend. Okay? And legend, you can specify things, but if you just don't specify anything, you could specify location and all kinds of things. But you're just going to slide with the default value. So if you don't specify anything, it's just going to place a legend where it thinks it's good. So this points to the fact that it is a function, right? As a function could have inputs. It's one. All of these functions are built-in functions. It could have input, but these functions often work with multiple types of input. If I don't give it anything, it's going to actually figure something out. Let's redo and see how different the plot is. Okay? So now I actually see those individual points that I created with my vectors x and y and x and y2. Okay? So this is my sine, this is my cosine. Default location works really nicely with this plot, so no complaints. So all I did is label sine and cosine and specify type of the plot. I can add as many as I want. I can keep going. Okay? I can add some other versions of sine times cosine or whatnot.
And here's one lens space. Is yours lens space?
Yeah, mine is lens space and 100 points. Change that.
Okay. Because mine looks like this, but I'm not sure. Is it an array?
Yeah, because that's a range with 0.5.
Okay, but it looks like this if it's in a range.
Try a range with 0.05. And then it's going to be smoother. Again, it's doing what you're telling it to do. Okay. Okay. Now, second thing that I might want to do is adding multiple plots in one figure, something like this one that I have on the side here. I have to do, again, data. I could just work with my sine and cosine, but I'm bored, so I'm going to change it. Okay? And I'm going to create two sets of data. And the key point here is to tell it, hey, this one figure is going to have multiple plots on it. And you tell that by the function with subplot. So you're going to have multiple plots. There will be two total. And plot 1, 1 will be one plot that you do whatever it is that you wanted to do. And then you're going to say plot subplot 2, 1, 2, or 2, 1. And then you're going to do the second plot. So the logic of it is if you have multiple plots, then you're going to tell it, hey, do subplots. And in location, the first location is 1, 1. The second location is 1, 2. 1, 1, 1, 2. Yes? And everything else is whatever it is that you wanted to do with the plot. So here I'm just plotting data, and this time I'm putting dots and line. I'm specifying a line and marker. And this is time axis, and this is an undamped cosine, and this is a damped signal. So basically I took a cosine function and I multiplied it by exponential that keeps kind of getting smaller. And that's damping the signal. I just made the data up. But the whole point is this key thing is subplot that tells it, hey, split this plot into two. It has to create two sets of axes. Has to know that. Okay? And the rest you design what you want to plot, and you design how you want to label it or not.
Why are you putting semicolons at the top there? After
Uh, Irrelevant. My old programming habit. If you put it or you don't, it doesn't care. Always good to check. So what have we learned today? You have to import, in addition to NumPy that helps us create arrays, you have to import the plotting module. We're going to call it PLT for short. That's the most common way to do in Python, so you're also going to see code that has that. You have to have data. How you create data is irrelevant. Here I'm just coming up with some examples. And your data has to be exactly matched. So if you're plotting XYs, both 1D arrays have to have the equal number of points. If they don't, trouble. And then you tell it to plot. The basic thing is plot XY, plt.plot of XY. And you can dress it up with labels, X label, Y label, title. You can add a legend. And then you can also modify how your graph looks like. It can have markers, it can have lines and colors. And you just kind of pile them up, whatever it is that you want. And the second part is you can do 2 subplots in one figure. And for that you need subplot commands. Okay? All right, I see you on Friday.
So there are 4 of you who I failed to find your mailbox, and I've already sent you an email. If you received it, your homework is here and from me. If you didn't receive any email,